Yes. Okay. Prathmesh is a seasoned software development and a machine learning engineer with around 6 years of experience. He has honed his skills across various technologies and frameworks, specializing in Java and Python. During his tenure at renowned corporations such as UBS and MasterCard. Additionally, he is a certified Scrum Master and possesses over 2.5 years of experience in efficiently and effectively leading high performance tech teams. Prathamesh's academic background includes an MBA, an MS, and a BTech degree, underscoring his multidisciplinary expertise. He is currently working as a software development and a machine learning engineer at Tactable Toronto. So, with his busy schedule, he has paired his time, early morning time of his schedule. So, I welcome you, Prathamesh, for this FDP. It is always a pleasure of hosting you as part of our FDP and as part of our institute. So, I welcome you to the FDP, and yes, over to you.
Thank you for the beautiful introduction, ma'am. It's my pleasure to be on this platform. Thank you to Vishwakarma Institute of Technology for giving me this opportunity to present here today. So, just to confirm, everybody, uh, what's on my screen, right? It's saying Agentic AI empowering autonomous decision making. Can
Yes,
I get some? Yeah,
able to say it, Prathamesh. Yes.
okay, perfect. Uh, Great. So, I'd want to keep this session interactive, and hence, I would be asking quite a bit of questions, and we also have a quiz with 10 full questions so that whatever we learn today and whatever 2 cents I can impart today, we go home by solving some questions and making sure that we really, really understand what we take home today. It's not going to be a lot, uh, but still, it would be substantial. So I hope everybody is nice and full after a good lunch. And after the last session, I hope the short break has given you a good refresher. So, um, with that said, question number one, can I get a quick chat on when ChatGPT was released? Can I get like the year? Can I get some inputs on the chat for, okay? Okay, I see a Chat GPT 2016 release. That's interesting. I wish I was getting that early beta testing access. Nice. So I have a majority here, which says November 2022, which is correct. So when ChatGPT came, it changed the entire ways of thinking and working, not only for students, because now as students, we could literally start being on the borderline of plagiarism or, hey, am I understanding this topic completely? Right? And even for the industry, the ways of working changed where the developers and project managers and everybody across the hierarchy had to make changes in the ways they think. And the industry is starting to move towards adapting more and more of AI. So with ChatGPT, we were now able to get questions and answers back to us. But now it's been already 2 years since ChatGPT is out, and now people are starting to think, what next? Right? So we will be discussing the hot topic of 2025, which answers the question, what next, or at least what people are looking at next, right? This is the publicly said hot cake, hot topic of 2025, which is Agentic AI, shaping tomorrow with empowered decisions today. This slogan has been prepared by ChatGPT. It's good. It's awesome. Cool. So let's have a look at our agenda. What's our agenda going to be like, right? First, we'll look at what is agentic AI. Then we'll move on to inspecting why do we need agentic AI. Like I said, when ChatGPT came, people are happy with it. We all use it. We all get a lot of value and a lot of benefit from ChatGPT. But what next? What are the shortcomings of traditional LLMs? It's funny how we have already started using the word traditional when it comes down to LLMs, right? It's just like it just came out 2 years ago, and now we are already calling it traditional, right? So, what's the difference between traditional LLMs versus agents? What is the history of agentic AI? Because guess what? It's not new. Agentic AI has always been there in some shape or form, but not like we are looking at it today. Then we'll dig a lot deeper into agentic AI architecture, and we'll also dig deep into design patterns in agentic AI because, like in software engineering, even agentic AI has design patterns. So, we would be looking at those. And like software development engineering, the design patterns over here are also a teeny tiny bit confusing, but that's going to be all right, right? Then we'll also look at a few agentic AI use cases. We will then look at popular frameworks that exist out there already, and there exist plenty of them, right? There's a plethora of frameworks already available for agentic AI. Then we'll have the uh, fabled quiz that I was talking about in the beginning, just to be sure that we are really taking home what we learned today. And then we'll look at a quick demo of agentic AI live in action. And then we'll open up the stage for question and answers. I'll take a quick pause here. Does that sound super cool to all of us? Okay. I can take that as a yes. I would have appreciated if I would have gotten yeses on the chat, but that's all right. I can assume it's a yes. We all are super excited. Thank you so much. Now we have a few yeses. All right. Perfect. So let's see what's agentic AI, right? In the paper by Huang Q and others in 2024, which reads by the title of Position Paper Agentic AI Towards a Holistic Intelligence. You'll find that on Arxiv. They say independent intelligence, purposeful action. That means agentic AI is a step above traditional LLMs, funnily enough, like traditional LLMs, in a way where LLMs are now able to, with the backbone of agentic AI, perform with autonomy, perform with their own sense of agency, and hence the word agentic AI. What does agency mean? Agency means the sense of acting independently in an ethical and correct fashion, or somewhere on these lines. Now, one analogy that came to my mind the other day was, hey, do we all remember Paul? There's this little nugget that I have, Easter egg that I have tried to put here. Do we all remember Paul the Octopus? Does it ring a bell like 2008, 2010? Paul the Octopus, FIFA, football, something? Yeah, so that's just exactly predicting FIFA World Cup, right? So agentic AI, if we try to compare it to Paul, the brain is the LLM, right? And the tentacles of the octopus are all the tools and the extra sensory input information that the agent has now, because you have a brain, you have arms, you have ways to act and perform in the real world. You see, ChatGPT, you ask a question, you get an answer, but ChatGPT is only stuck at giving you an answer. It'll never be able to do things on your behalf. And hence, if we all have noticed, people have started using structured outputs for ChatGPT, where you have JSON output, where you structure the output, and then you process that output in order to perform a subsequent action. It can be sending an email, it can be updating a database. Essentially, this is also something that marks the birth of agentic AI, where people slowly started to use Chat GPT and LLMs, to be a bit general, right? It can be Chat GPT, it can be Mistral, it can be Gemini, it can be all any and all LLMs, right? People started using LLMs to structure their output to take decisions and then follow subsequent action. But then there is an interesting question that might come to your mind or all of our mind. Definitely came to my mind. Hey, how is agentic AI different than me writing a program to call ChatGPT to ask some question, get a structured output in JSON, process that output, and then take a decision based on that output? Would that be agentic AI? Yes and no. A form of agentic AI, but a very crude one. But that's the right idea. That's how the idea of agentic AI with a backbone of LLMs was born, right? So that's in a nutshell what agentic AI is. Moving on, why do we need agentic AI in the first place? Like I mentioned, you observe that ChatGPT is locked into its own environment. You ask questions, it gives you answers. You can't really make ChatGPT do things. You can't really, essentially, ChatGPT is stuck within itself, right? So let's first explore what LLMs are good at. Definitely, they are good at understanding language. They beautifully understand what we want to say, even better than humans, right? Sometimes humans misunderstand us more than ChatGPT does. It's such brilliant at understanding language, right? It has leveraged vast amounts of training data to answer diverse set of questions. You ask questions from psychology, you ask questions from medicine, you ask questions from anywhere in the world, and ChatGPT always has an answer for you. And LLMs can adapt quickly to new tasks. For example, prompting, few shot prompting, chain of thought prompting, and all the different styles of prompting, which now are famously called prompt engineering. And that's, according to research, one of the highest paid jobs. It at least was, I'm not sure about 2025, it's just started. But in a nutshell, LLMs are really, really good at adapting to new tasks with minimal examples, right? Zero shot, few shot prompting. However, what are the short terms with external systems? I think I have overdone stating this point now that they cannot interact with external systems, right? Second, they really lack persistent memory across sessions or long workflows. That means ChatGPT, at a bare bones level, just takes an input, which is a sequence of tokens, and gives an output. How does it give an output? It completes the sequence of tokens. It's taking the sequence of tokens up till n, trying to make the n plus one word. Again, it does that, rinse and repeat, right? However, it does not have memory. But you may ask, hey, ChatGPT has always had memory, right? It remembers our conversation. It remembers the context of our conversation. How can it be that LLMs don't have memory? Inherently, they do not have memory. You give an LLM an input, it gives you an output. Inherently, the system does not have its own memory. It's externally implemented by chatgpt.com, right? It's not there in the LLM as its own architecture per se. Also, as we all have observed, when we have tried to ask ChatGPT, hey, can you please write a program for so and so? And ChatGPT gave us the program, especially the early versions of LLMs, where I remember GPT 3.5 and 3.5 Turbo, it used to be quite suboptimal, like quite below average when it came down to giving correct code in the first go. And in general as well, even today, LLM struggle with giving out good code sometimes. Now it's starting to reduce, but still it's there. And especially when you start giving the LLM questions like, hey, I'm having this error. Can you fix this error for me? The LLM is going to do an average job at doing that because you're going to be going back and forth with the LLM trying to fix the error, and the LLM is just going to spin round and round, not figuring out what you're really wanting to ask. And that's the big shortcoming when it comes down to error handling. All right, so what's the difference between traditional LLMs and agents? So far, we have been talking about precisely this, but quickly to recap, traditional LLMs, question answer based, respond reactively to user provided inputs. They are not proactive. You have to ask, they answer. You ask, they answer, right? It's reactive and not proactive. It's stateless with no memory across interactions, like I mentioned. It's limited to providing information and not autonomous action. Like I said, can't interact with external systems. It cannot take its own decisions. It cannot wake up from sleep one fine day and start taking actions, right? However, on the other hand, agents are goal driven. Goal driven is a very important word here, or rather, the paramount word here in terms of importance, because agentic AI is based off of the idea of having goals and planning towards achieving those goals. Just like we say in our own human lives, right? We all should have goals. 1 year, 2 year, 3 year, 5 year, 10 year, right? And then we should make the necessary planning steps towards the goal. So agents are goal driven with autonomous decision making capacities. Autonomy is their own ability to plan and execute what they have planned, not what we have asked them to, right? Second, it's agents can solve problems proactively without constant user intervention. Integrate tools like and APIs for dynamic task execution, which means agents can connect with SQL databases, SQL databases, NoSQL databases, MongoDB, DynamoDB, PostgreSQL, anything and everything. It can connect with your Gmail account. It can connect with Jira for the counterparts who are listening to me who work on Jira, right? It can interact with Jira. It can interact with Confluence. It can interact with GitHub. It can essentially interact with external tools. And that's an awesome thing. It can perform multi-step tasks to achieve defined objectives. Where do objectives come from? Objectives come from goals. What is the goal? The goal is the user-defined goal. It has to start somewhere. So the goal is the user-defined goal, and the objectives are the plan that the agent has made in order to perform steps according to those objectives and eventually achieve the goal, right? Maybe, just maybe, I can take a pause here and have a quick check if anybody has any questions so far, or is everybody good so far? And is everybody very happy with their coffees right now in the afternoon? Can I get a few interactions on the chat? Maybe yes, no, maybe. All right, that is perfect. Okay, let's go over the history of agentic AI. Like I said, agentic AI, agents is not a new word. It's been there in some shape or form. For example, if we go way back in the 1940s or the 1950s, we see that Alan Turing was proposing early intelligent machines and AI mimics were being created in terms of automating things. And this exact timeline also goes for when you speak about the history of AI in general, not just for agentic AI, but in AI as a whole, right? Through 1980s and 1990s, we saw emergence of agent-like systems. For example, robotics, we saw a lot of computer vision, and we saw a lot of things where we were seeing glimpses of a terminology like agents, right? Through the 2000s, we had an immense rise in machine learning. Everybody was doing machine learning. Through the 2010s, we had practical applications across industries. Robotic process automation was being used, where we can associate the word agent in terms of robotic process automation, right? Industries were trying to automate the mundane tasks in terms of process automation. Siri was a brilliant example. Autonomous vehicles were starting to be worked on, right? And now, post 2020s, agentic AI has come into the picture where we now have immense computational power. We have immense data. As they say, in 2000s and 2010s, data was a, a valuable item. The companies who had a lot of data, like a decade or 2 decades ago, they were the kings of the space, so to say, right? Metaphorically. But after the emergence of large language models in ChatGPT per se in 2022, data or availability of data and information and other things, people have started to say that it's no longer that important, right? Because we have so much data, we have so much processing power, there are plenty of LLMs which have learned from tons and tons of data. So moving forward in 2025, they say it's the top technology trend, which is agentic AI. I'll take a minute here. I will be just back. I'll just grab my water bottle and my coffee. All right. Perfect. I hope we have everybody here still. That was really quick, but yes. Okay. Uh, Beautiful. Let's move on. Let's look at what agentic AI architecture is. First, we have an input. Just like we have in large language models, we have an input. That's the user prompt. In this case, we are calling that as goals or inputs, whichever way. But in agentic AI architecture, inputs are more of your external connections, which is, hey, the agent can talk to a database. So the input is the function that can talk to the database, right? So goal is the real user prompt in this scenario. In case of an agentic AI, goal is the real user prompt. Hey, can you tell me what is the answer if I do 2 plus 3 into 5 minus 10 plus 50? right? Some random mathematical equation. And as an input, you give a function that is a calculator. Because even today, GPT-4 is bad at counting the number of R's in the word strawberry. It ends up telling you it has only two R's in the word strawberry. And even today, it gives a wrong answer, right? Um, so essentially, your inputs are all the functions and the external connections. It can be your SQL database, it can be your Jira, Confluence, all the jazz that I mentioned, right? And goals is your user prompt. Now we start digging deeper into what the agentic AI system looks like. The main components of the agentic AI system are orchestrator, memory, LLM, executor, and planner. Let's go over and tools. Let's go over them one by one. The orchestrator receives the input request from the user along with the additional information about what tool access it has, what the other inputs that I mentioned, right? Then the orchestrator has the responsibility of talking to the planner and talking to the executor, right? So in a flow, in a typical flow, the orchestrator receives the input. Then that input, along with the additional functionalities and tool accesses and external connection functions, all accesses, right? It goes to the planner. Now, the planner is responsible for making a plan to reach the goal, right? It has a goal. What is the addition of 2 plus 2 plus 4 plus 3 into 65, right? And as an input, it has a calculator. So the planner wants to make a plan about how it will go about doing that. So it then goes and asks the LLM that, hey, this is the goal that the user has provided. And the user has also told me it has access to Jira, it has access to Confluence, it has access to a calculator, it has access to 1,000 different things. And this is what the user wants to do. For example, let's take an example of project management. Maybe calculator's example is a bit too naive. In case of a project management, the planner, we let's say have uh, a target or a goal of sending a weekly report, right? So it has to look at Jira, it has to look at email communication, it has to look at GitHub, it has to look at a different thing, right? So the planner will ask the LLM, hey, can you tell me how can I build a weekly report? Given the fact that I have access to Jira, I have access to Confluence, I have access to GitHub, I have access to 1,000 different things, right? Then the LLM says, "Oh, that's perfect," right? So go to Jira, download the sprint report, weekly, bi-weekly sprint report, right? Then store that in the memory, right? And hence we have the memory component. And step number two is go to Confluence and check what documentation has been updated with respect to the code base and fetch that documentation, summarize that, and store it in memory. Step number three, go to GitHub and check what are the latest commits that have been done on the code base. And take a note of those commits and determine what changes have been made and store them in memory. And step number four is collect all of this and send it to the LLM in order to prepare a report. Right? So the planner is responsible to create this plan. But how can the planner create the plan, right? It's responsible to do that, but how can it do that? It makes use of the LLM, right? It just delegates the work to LLM because that's the brain. That's the main brain we are talking about. This all is built on top of LLMs, right? So the LLM says, do these things, blah, blah, blah. The planner now has a plan. So the planner takes the plan back to the orchestrator and says, hey, you asked me for a plan, you have a plan. So the orchestrator says, perfect, let's go ahead and execute the plan, right? So then it reaches out to the executor, says, hey, I read in this plan, step one is go to Jira, download the sprint status report. The executor takes that request. The executor understands, okay, I want to go to Jira and download a weekly status report. The executor asks itself, hey, do I have access to Jira? Is there a tool, right? Is now we are talking about tools. Is there a tool which I can use? That tool can be a function, a Python function that can access Jira and that can read the status programmatically, right? You access the Jira API, you pull the status, you're happy with it, right? So the executor checks, do I have a tool for this? The executor says, yes, I have a tool for this. So the executor picks that tool and executes on that tool, right? So essentially, that tool is responsible to go get the weekly status. So that's how the executor says, okay, I am done executing, goes back to the orchestrator, gives the result back to the orchestrator. The orchestrator says, okay, we have a Jira weekly report. Over here, the orchestrator is now responsible to verify whether that weekly report is correct or not. Has the executor done its job correctly or not? Now we are also introducing the concept of adversaries, right? The orchestrator is acting as an adversary to the executor. The orchestrator is acting as an adversary for the planner because as soon as the planner gave the plan back, the orchestrator again verified that plan, whether that plan makes sense or not. So here we also have logic and thought process, which is also talking about having an adversarial connection, interconnection between the components of the agentic AI system, right? Good. Are we following so far? Just a quick question, just trying to make sure we all are here, nice and fresh. Everybody's having coffee, nobody's sleeping after afternoon lunch. I can understand previous session, right? So is everybody with me? Everybody good? So far, so good. Are we understanding stuff? Is it too difficult? If I can have feedback and on the fly I can make my script change, right? Yeah. We good? Yeah, okay. We good. Cool. Let's move on. Let's try to inspect in a bit more detail. Give me a minute. I'll just take a sip. Yeah. We'll try to inspect what are goals and all the individual components of the agentic AI system, right? Let's look at what are goals. Like I've said so far, goals primarily come from the user, where the user says, hey, I want to make an agent which constantly monitors my inbox and reads any new emails that are coming my way and send me notifications on my phone or send me a WhatsApp message because we all have our personal Gmail inboxes full with advertising emails which we never see and we never want to see. And I don't know why, even today, I'm not that happy with Gmail's experience because I end up missing so many emails. Right? So let's say I want to have constantly monitors my inbox. Whenever I have an email, it reads that email. And if I have something which is utterly, utterly important, like I'm missing the my tax date, for example, if I'm missing my rent payment, if I'm missing my Netflix payment, right? If I'm having any important email, it immediately flags that out to me, right? So this is the goal. This is what I am defining that, hey, I want an agent like so. I'm saying that, hey, I want an agent that does this, right? So this is the goal that we are really trying to define here, right? For example, a few more examples could be debugging code. Let's say I want to make an agent that analyzes my GitHub project and constantly makes sure that the code quality is always up to date irrespective of whatever reviewers I have. Of course, every company, every organization, even college projects, we all review each other's code and we all should be doing that diligently. But we all have human errors, right? So my AI agent wants to constantly monitor and make sure that there is no memory leak, the code quality is up, like very fine, fit and fine, everything is fine. Another example could be route optimization. Another could be report generation, like I said. So again, goals are what we define. It's just like a prompt for an LLM, right? At the same time, it's the heart of where the agentic AI system starts because it's going to make a plan based on the goal, right? The better you define your goal, the better will be the plan, and hence the better will be your execution, and hence the better will be your result, right? Beautiful. What does the planner do? Like I said, the planner creates execution plans to achieve agent goals, which is key important points here are it maintains a tool inventory that, hey, as an agent, I have access to Jira, I have access to this, I have access to that. The planner is always maintaining in his or her, no, yeah, in its memory what the tools available to it are. And also, it is responsible to map the tasks available to tools, right? Essentially, the tasks that are coming out of the goal when the LLM says, do this step number one, do this step number two, do this step number three, the planner is responsible to correctly associate what tool is appropriate for this task in a way by again prompting the LLM itself. Because when we talk about the planner, it's responsible to do all of these things. Who does it delegate to? The LLM, right? Everything is essentially being delegated to the LLM, but the planner has to fulfill these responsibilities that it has, right? For example, if the goal is to retrieve return policy for items in order 1001, let's say we are taking an example of e-commerce, right? The planner will essentially eventually come up with a plan using LLM that, hey, I need to use tool one to list the items in the order. And then I need to use tool two to fetch return policies for these items. And then I will combine all these policies into a single response and then deliver the formatted response to the user as the final output, right? So this is essentially what the planner is really intending to do. Moving on, the orchestrator and the executor, these two things are sometimes clubbed together in one framework and sometimes kept apart in the other framework, right? Because in a way, if you try to look at it, the orchestrator and executor, the roles that these two items are, or these two components of the system are playing, are more or less can be overlapped, right? Because the orchestrator is trying to make sure that everything is coordinated, the workflows are correct, the system is communicating well within each other, the planner is able to make a plan, the orchestrator is reviewing the plan, the executor is executing the plan, the executor is talking to the tools, the planner is maintaining the inventory for the tools, the LLM is talking to components, then we also have a memory component. What should be stored in the memory? What should not be stored in the memory? Do we have a long-term memory? Do we have a short-term memory? Do we have a mix of that both? What should go in the short-term memory? What should not go in the short-term memory? All of these items are being taken care by the entire system. And hence, here we can say that the orchestrator and executor are responsible for making sure that all of this coordination and coherence in the system is being maintained. Especially the orchestrator has this priority The executor is more of the workhorse per se, right? So to say. For example, let's look at the example that's on the screen. User requests order return policy from the orchestrator, or orchestrator sends the goal to the planner for tasks. Planner suggests using tool 1 to retrieve order details. Executor runs tool 1 and sends results to the orchestrator. Iteration continues until final policy is generated for the user. So the orchestrator and executor and the entire agentic AI system is less of a unidirectional flow, but it's more of a mix of unidirectional and having circles in between, right? It eventually gets back to the user. So it's still sort of flowing in one direction, but internally it can have loops. And that is where autonomy really comes into picture. These loops that we talk about, this is where the agent is thinking, making a plan, making mistakes in his in its own plans, fixing those mistakes, right? And then executing those and then making sure that those results are correct and then returning the output to the user. These cycles really give the power of autonomy and agency when we speak about agentic AI, right? Next, like I have been yapping continuously so far about the tools that we are talking about. Again, to recap, tools execute actions, like we all know so far. For example, retrieving or changing external information. If you want to update a database, if you want to read data from a database. Last time in uh, last year's FDP, I presented on retrieval augmented generation, which is also now one of the tools that can be used with an agentic AI system. So, uh, if anybody has attended last year and remembers something out of last year, then RAG system, or in nonetheless in general, right? RAG systems are more of augmenting the user query by retrieving information from custom slash domain data, which ChatGPT slash LLMs are not trained on. And this enables the RAG systems to really boost the performance of the LLMs. So now RAG systems are a part, they are a tool in the whole agentic AI architectural landscape, right? Tools can also be calls to LLM models, which are configured with a different system message. One LLM model can be configured with a system message that says, hey, you are a medicinal professional. The other one can say, hey, you're a research assistant. The other one can be, hey, you're a pharmacist, and so on and so forth, right? Let's look at another example about tools. I don't think by now we really need to have another example about tools, but yet here I will give another example about tools, right? So let's say we have a cloud storage API for document retrieval, right? Tools profiles specifies the inputs, formats, and output structure. Actually, this example was very important to give because the key points about a tool and the definition of a tool is that it should loudly broadcast what the inputs are, what sort of inputs does that tool take, in what format does that tool take the inputs, and what format does the tool give outputs in. And it should also specify essentially the output structure, right? And the internal workings of the description of the tool. So as long as the tool is able to self-identify itself with these three things, input, descriptions, definition of the tool, that what does it do? Hey, I am a tool which can go to Jira, I can do all of this, right? So it self describes itself and it says what sorts of outputs does it give. Imagine a tool to be a function. Even a function has these three key things that you really need to have in place to even call a function, right? Input, processing, output, right? So tool also identifies with the exact same set of parameters, right? Input, processing, and output. Beautiful. Moving on, let's discuss about the brain, which are the LLMs, like I've been saying. They are responsible. LLMs are the primary piece or the module that is responsible for making intelligent decisions. Whereas the entire agentic AI architecture is more of a framework and a way of putting things and systems together that perform magically well, that perform wondrously well. Agentic AI is more of a way of putting things together and less of being the brain itself, right? The brain over here is still the super smart LLMs that we know, right? We are augmenting and putting them in a structure which now yields us way more beautiful results. And in today's demo, we will have a look at what beautiful results all of a sudden one shift from LLMs to giving LLMs a nice structure around them can cause, right? We will have a look at that demo, and I hope that demo is as mesmerizing for you as it is for me, right? But amazing. So again, LLMs, the brain of agentic AI systems, right? I'm concerned we might be falling short on time, but I'm not entirely sure. But let's see how it goes, right? I'll take a quick pause here. Everybody is good so far with me? So far, yes, no? Okay, beautiful. Thank you. Beautiful. Moving on. Memory in agentic AI. Like I mentioned, two types of memories here: short-term memory and long-term memory. Right. Memory, as we know, is essential to provide context and history for planning and decision making. Some goals can be complex or long running enough. For example, constantly monitoring weekly reports and making sure if there are any inconsistencies in weekly reports. Those reports can be about anything. Those reports can be our own personal reports as well. If we are a student, those reports can be about our own performances. And these things can be long running. You might want to analyze your results over 3 years, over 4 years, over 5 years. You want to analyze your results over a decade, right? So here you really need, if you want a successful agentic AI system or an agent per se, you have to have the long-term memory component in it. Whereas short-term memory is more required when you really want to track intricate workflows. For example, you're trying to debug a broken piece of code. Something for folks from the industry who really resonate with my feeling, what I'm saying here. Something breaks in production. You're there 3 a.m. in the night trying to fix that. And you're really trying to see what broke, how did it chain back through the events, and what exactly was the point which you need to fix, right? As it is said in a very famous quote that you need to hit the hammer at the right spot, and hence you need to really take your time trying to analyze where it really all broke. And here is where short-term memory really works like a charm. And even for us humans, right? We really need to have that sense of short-term memory because we really need to remember what the workflow is. And over here, in case of agentic AI as well, it's really imperative to have both short-term and long-term memories. Moving on, let's look at a few use cases of agentic AI. Throughout the sessions, I also read one of the sessions is going to be on applications of AI in finance, or yes, if I remember it right, right? So one of the impressive like use cases in finance with respect to agentic AI are essentially automating fraud detection by analyzing transaction patterns in real time. Of course, these systems even exist today. Credit banks, huge financial institutions, even today have excellent fraud detection systems, no doubt about it. But imagine if that augmented by the power of LLMs and agentic AI. How cool that would be, right? It's not just going to be cool, but it would happen really, really soon, right? Because it's really picking up. Anybody know Krish Naik? Can I get like a quick yes or a no? Krish Naik. Anybody uh follows him? Yes, beautiful. So you must have really recently seen his video series where he is also pretty hyped about agentic AI, right? He is also opining along with several others that agentic AI is going to be the thing about 2025, in 2025, right? Moving on, generating personalized investment portfolios based on client financial goals. This one can be an absolutely hit item in terms of applying agentic AI in finance, right? The agent can really monitor your own expenses, your family's expenses. It can monitor how you can use your wealth in order to create much more of it. And that would be so awesome to do that, right? We have a lot more applications in customer care, resolving customer queries, talking to people, proactively identifying customer needs, understanding what the customer wants. All of these items can be enhanced in the space of customer care. We have insurance, processing risk claims, risk assessment, what amount of insurance or premium to charge for different people based on what their medical histories are, based on insurance can on that end also optimize a lot of things based on how they can add variability and precisely handle their insurance space using agentic AI and the power of LLMs as well, right? Human resources, job screenings, automating employee onboarding, workflows, project management. This is really interesting, right? Project management is a space which can really help from agentic AI systems, where first, like I've been mentioning it 1,000 times already, generating progress reports, right? Which is an absolutely amazing idea to implement in agentic using agentic AI for project management, right? A lot of managers, even today, are spending their time making reports. It's a hard truth, but uh, maybe it's not like some verified truth, but that's what I look at it, right? And that's what how many others all around the globe look at it, right? A lot of us spend a lot of time generating reports, which can be automated. Optimizing resource allocation by analyzing workload and deadlines. This can be a little intrusive when you're really trying. I see a hand raised. I will answer or take that question in just a moment after finishing my current thought process. This idea might be a little intrusive when it comes down to the agent checking on somebody's GitHub commit history and saying, "Hey, I think you know what, you've been chilling lately, right?" That might be a little intrusive, but yeah. So A lot of AI use cases, beautiful use cases. We have a question we had a question from somebody. Can we open that? Sorry. Uh, Somebody had a question.
Did anybody have a question? Somebody had raised a hand.
Okay.
Okay.
I will probably wait for somebody else to raise another hand. For now, I can probably proceed. Perfect. So let's look at an example, a really, really quick example of um, a project management use case where we are um, getting to see how an agentic life cycle is, right? So starting off, we have a goal, generate a consolidated report and share it with stakeholders. The input is prepare a weekly project report with task statuses, right? The orchestrator takes this, receives the input, identifies the tools and assigns the responsibilities, right? Now planner's responsibility is to plan. The planner takes the input, breaks down the goal into tasks like fetching data and formatting and all the other tasks which would be similar to these when we are talking in terms of creating a report, right? LLM over here as a module that we have looked so far, right? I'm just trying to put everything together in a single use case example where we can see the agentic life cycle along with each component at play, right? The LLM creates queries to retrieve data and generate the report draft. Moving on, the executor calls tools like Jira for tasks and Excel for reporting, right? Now, over here, like we said, right, the executor has tools to access and it can call those tools. The memory component over here, it tracks what tasks are completed, what tasks are remaining. After completing each task, it stores the results of those tasks in short-term memory first. And once the task is over, it'll lift and shift that out to the long-term memory, which will then be stored for any later references, right? Moving on, a few more tools like email systems are then used to share the final report with the stakeholders. Whatever stakeholders you have your director, you have your senior director, you have your client, you have the client's developer. He's going to ask questions, right? Like whatever the stakeholders are, the agent updates progress iteratively, improving with stored memory. Stakeholders receive a well-compiled report with minimal human involvement. Now, over here, when we say minimal human involvement, that means the autonomy in terms of what can be autonomous and what needs human approval will differ case to case. In a medical space, the regulation would say you cannot have agents on their own. Sure, get them ask them to make a plan, ask them to do everything, ask them to verify the plan, everything, but the execution engine will be highly regulated in a medical space, in a pharmaceutical space. Whereas in other spaces, the agents can act with a little more autonomy, right? Perfect. Let's explore a few design patterns for agentic AI. Agentic AI, okay, we have a question from Ashish Kumar Dhar. Yes, Ashish, you cannot speak. Ask to
Just,
unmute. Sorry.
just,
Yes.
just a moment. Yes, I will do that.
Hi, so this is Ashish. I will be actually a speaker in one of the sessions later on. So very interesting topic and getting myself educated on this very recent advancements in AI. I think one of the areas, because I'm a data security and privacy practitioner, we talk about a lot of things around AI, about explainability, transparency, ethical biasness, and everything. And for all of that, we have a human in the loop concept where I think you just touched on the medical use case, where the human in the loop is going to verify, validate, and then maybe certify some of those tasks or actions to be uh, executed, or maybe they can kind of put a block to that. So where in the architecture is that human in the loop coming right now?
Absolutely. That's a brilliant question. Thank you so much, Ashish, for asking that question, right? It's right. So to answer your question, let's go back a few slides. Looking at the architecture, the executor is the point where in the system you have a provision for the human to come in the loop, like you mentioned, right, Ashish? So the point where the planner prepares the plan to execute a goal, that is where it gives it back to the orchestrator. The orchestrator makes the plan as nice and valid. And once the plan is made, instead of directly giving it to the executor, there will be a human in the loop at this point, where the human will, anything before it gets executed, the human will approve. For example, in if you make a bot for yourself in for finance, let's say you want to make a bot that trades on behalf of you, right? Using your account, whatever, right? So it's a personal bot. You make that bot using Agentic AI, but now you really want to be the human in the loop, like you mentioned, right? Before it really uses your money in real life and makes that trade, right? You want to be notified that, hey, I observed that in the next 3 months, this thing is going to go up. And I think in the next 5 days, any time can be the right about, can be right about the time when you can put in your money. Do you want to do that? And this is where you can be the human in the loop, where you really authorize the execution to the executor. Does that answer your question, sir?
Yeah, yeah. Thanks.
All right, perfect. Thank you for the question. It was actually a nice question. Thank you so much. Cool. So moving on to design patterns, we have more or less 4 to 5 different design patterns. Of course, like design patterns being design patterns, they can be a teeny tiny bit confusing to wrap the head around. And at the same time, these design patterns are not independent. A few ideas can be overlapping with each other, right? However, broadly, the industry seems to have laid down these design patterns when it comes down to agentic AI, right? It's still evolving. Frameworks are in the baby stage. Everything, it's just come, right? It's just come in with respect to LLMs, right? Of course, when I said it's not new, I did mean that it's not new, but then with respect to LLMs, it's like literally just come. So the major design patterns that have been laid down are reflection, routing, tool use planning, and multi-agent systems, right? Let's look at what the reflection pattern is. I might pace through this a bit, as we might be running a bit short on time. I really want to show the demo, and I don't really want the demo to be cut short, but let's see how that goes, right? So the reflection pattern is, I have been mentioning about this since a while now. I have been, in some shape or form, mentioning about this reflection pattern where the LLM acts as a reviewer or evaluator for tasks. It essentially uses criteria to assess responses and suggest improvements. Essentially, when the planner receives a plan from the LLM, the orchestrator gives that plan back to the LLM, this time a different LLM configured with a different system message that uses a particular criteria of assessment, right? Which will get assessed by the LLM, which is configured a little differently with a different system message, right? With the correct criterion to assess the responses, right? Here, this is where we start talking about the adversary, right? The reflection pattern really focuses on making sure, double checking what you have done, right? So it's more of a critique. Moving on, the routing pattern, it selects paths based on alternate action profiles. Essentially, hey, I need to send out a message. Do I need to send out a WhatsApp message or do I need to send out an email message? Or do I need to send out a letter message, right? So this is where we start talking about the routing pattern. Remember, these are design patterns, right? So one way to think about when designing agentic AI systems is to ensure that it has reflection in it, right? Then the routing pattern comes into play when we have something that has multiple options and we need to take one of those or multiple of those options, right? This is where the routing pattern comes in. The tool use pattern. The tool use pattern is a bit of a no-brainer, at least for me. It's like I was not amused by this design pattern. I thought to myself, hey, I mean, isn't that obvious? Like agents, tools, like, isn't that obvious? But yet it exists. In this pattern, the LLMs really decides what tools it is going to use for the goal, right? Essentially, we spoke about the routing pattern, which was to decipher again, sort of what tool to use. It's again falling in the same category, but the subtle difference over here or the nuance over here is the routing pattern is trying to take decision between a same category or the same family of decisions. However, the tool use pattern is trying to decipher at the first level what it needs to do in terms of what tool I need to use in order to send an email. Okay, should I send an email or should I send a text message is decided by the routing pattern. But to send an email, I need to use a Gmail SMTP tool is decided by the tool use pattern, right? Then we have the planning pattern. Again, all of these patterns make up the agentic AI system, where the planning pattern is responsible to plan. Here we are talking about the planner. Break down complex goals into sub goals, tasks, objectives, subtasks. All of these tasks are mapped to routes, tools, and actions for execution, right? Moving on, we have the multi-agent systems. Now we are talking about groups of groups, right? WhatsApp, I think 2 years ago, came up with the community update, right? When they already had groups, but then now they have like groups of groups, sort of, right? That's how I take when I look at like the community feature of WhatsApp, right? It's like a group of groups. So multi-AI agents, multi-agent systems are groups of agents. It's like a team of agents. Like tomorrow, we might have organizational agents, right? If you even try to add a layer on top of that, like you look at an agent like a human, you say, okay, we have an agent. Now you say you have team of agents, right? So you say multi agent systems. And then you might like we might see future trends that there are teams of agents, multiple teams of agents working together, and they would call it an organization, right? Because that's what it means, right? That's how it makes sense. Cool. So popular frameworks for agentic AI systems: LangChain, LangGraph, Crew AI, Phi Data, Microsoft Semantic Kernel. super popular frameworks, and many more. It's a little hard to include these frameworks on the slide. And beautification is not my forte. I'm more of a CD, LS, MKDIR, CAT, VI sort of a guy, right? So it's really difficult to punch many logos in a single slide, but there is a whole array, a vast array of libraries available out there to work with agentic AI, right? And it's amusing that it's so fast. Uh, People out there are really, really working, right? Cool. Quick quiz. Quick quiz. I would need a few faster responses over here because we have 15 minutes left, according to my understanding, and we want to still do the demo. So let's pace through the quiz. Let's try to um, go through the quiz as quickly as possible on the chat. Maybe chat. If everybody still has energy after sitting through how many minutes? 1 hour, 15 minutes already. Let's go through the quiz, right? So, what is a key challenge in using LLMs in agentic AI system? One, option A, right? Lack of sufficient training data. Option B, high latency and cost implications. Option C, limited ability to generate outputs in multiple languages. Option D, inability to use fine-tuned models for specific tasks. What do you think the option is? Okay, we have D, we have C. Okay, we have D, we have D. Okay. Uh, okay, I'll quickly share the reason why D is not the answer. Let's read through the question again. What is a key challenge in using LLMs in an agentic AI system? So, to use LLMs in an agentic AI system, if the key challenge has to also be applicable to the LLM, are LLMs bad at being able to be fine-tuned? No, I don't think so. LLMs are pretty good at being able to be fine-tuned, right? Like, in order for LLMs to be a challenge inside AI, agentic AI systems, you really have to think about the challenges that LLMs have. I don't think LLMs have a challenge with fine-tuning, right? C is also uh, a wrong answer. Limited ability to generate outputs in multiple languages. LLMs, ChatGPT can generate outputs in more languages than a human can speak, right? That's also like a wrong answer. A is also a wrong answer. LLMs are trained on a huge data set, right? That's what the whole premise is. It's trained on a huge data set. Hence, the correct answer is B. The main challenge in using LLMs is high latency and cost implications. Even today, not even today, like today, LLMs are really, really costly to use and they have a high latency. Every time you're calling an LLM to first plan on how to achieve the goal is going to take like 1 or 2 seconds to get the response, right? Or it might take 500 milliseconds to get the response. So essentially, for your entire thing to happen, that's the main challenge in agentic AI systems right now. They are not blazingly fast, right? They are not like super fast. They internally they'll plan, they'll make the LLM call, the LLM will respond in 2 seconds, and it'll do something more, it'll verify, it'll go store in the memory, right? It's a huge hassle. Question two, what's the primary role of the planner in agentic AI? Option A, executing tasks using tools, coordinating system communications. Option B. Option C, creating an execution plan to achieve goals. Option D, providing memory capabilities for past requests. Can we have an answer for this? Creating an execution plan. Perfect. That's the correct answer. Beautiful. Question three, what does short-term memory typically store in agentic AI systems? Tool profiles and system capabilities, workflow history for a single goal or chat, archived observations across multiple sessions, fine-tuned model parameters. B, workflow history for a single session. That's correct. Absolutely. Amazing chat. Y'all are doing beautiful. Amazing. I feel really good. Amazing. Question 4. What's the orchestrator's primary role in agentic AI? Generating final user outputs, coordinating communication between system components, maintaining memory for the agent, fine-tuning AI models. Let's go for B. That's beautiful. Amazing. Question 5. What does RAG stand for in agentic AI tools? Retrieval augmented generation, random access generator, resource allocation guide, real-time action generation. Amazing. Beautiful. Someone said C, but okay. That's amazing. The correct answer is retrieval augmented generation. Let's go for the next one. We are talking about design patterns now. Remember, tricky questions, right? Design patterns. But let's try to solve them. In the reflection pattern, what is the key mechanism? What is the key mechanism by which an LLM improves its outputs? Re-executing the original goal until the output improves, critiquing the generated output based on predefined criteria, calling external tools to improve accuracy automatically, generating multiple outputs and selecting the longest one. We have multiple answers here. We have B, we have A. We remember we are talking about the reflection pattern. What does reflection mean? Looking back, whether you have done it correctly or not. That means criticizing your own work. Does that ring a bell? It does. It's B, right? Amazing. Amazing. In the routing pattern, how does the LLM decide the best route? Based on user feedback after executing all actions, randomly selects the route, matches input goals to action profiles for optimal selection allocation guide, directly executes the first route defined in the workflow. C, beautiful. Amazing. It's amazing. Right. Question 8. In the tool use pattern, what additional capability does the LLM require? Memorizing all tool outputs for future use. Deriving and supplying input parameters for tool execution. Randomly selecting tools to ensure all are tested. Storing tool outputs permanently in long-term memory. B, there's a majority for B. B for beautiful. This is amazing. Yeah, absolutely. Question 9. What's the role of the LLM in planning pattern? What's the primary role of the LLM in planning pattern? Reviewing sub goals after their execution for potential errors, creating and assigning subtasks to tools or agents, executing each task in the workflow independently, generating a single output without sub goal decomposition. We are answering C, we are answering B. Okay, let's read what C is. Executing each task in the workflow independently is the primary. Is it executing like the planning part? Like the planner is like, no, it's not executing. I think it's more of, okay, let's try to read B, creating and assigning subtasks to tools or agents. Beautiful. It's B. Question 10. How do multi-agent systems handle complex workflows effectively? Use a single agent that switches between all tasks, creating new agents dynamically for every new task, coordinating specialized agents with distinct responsibilities for tasks, centralizing all logic with orchestrator to avoid multiple agents. What do we think? We are looking at B, we are looking at C. C is the right answer. That's correct. Beautiful. Amazing. We will go over references, but we'll not go over references. These are the references that I have used. Essentially, I have gone through a LinkedIn course. I have gone through the paper that I mentioned. I have also read through Couchbase for one of their agentic AI blogs. I have also referred to Microsoft's official website to learn more about semantic kernel, which was one of the frameworks that is available out there. I have also read about what are the top 5 frameworks for building agentic AI systems on Analytics Vidya. I've also read through Phi which is on which I'm going to give the demo today. I've also read through LangChain. I've also read through LangGraph. Both of them are langchain.com, but one of them is an extension to the base one. The other one also that I went through lightly, briefly touched upon was Crew AI in order for preparing the entirety of this session, right? Let's look at a quick demo. We have 7 minutes. I am in no mood or intention to hold anybody for more than what we have signed up for. And hence, I will quickly change my window. Can everybody confirm you can see my window?
Yes, yes, we can see.
You can see a
Yes, sir.
bunch of code on my window, right? Okay, we can see code on my window. Beautiful. Cool. So sorry, let me quickly first, instead of directly jumping on to code, I will first try to show the documentation for Phi data so that we really understand what we are looking at, right? So I'm back at Chrome. Can everybody see my Chrome? Can I get a quick yes or no? Or like, I mean, if you can see, I want a yes, right? I mean, okay,
Yes.
beautiful. Right. Sheesh, I didn't want to show the thank you slide right now, but yeah. All right. We have Phi data, right? This is one of the frameworks that I have used in order to prepare for this demo. It's a really small demo, but quite an impressive one, especially when it comes down to faculty development program in terms of when we are talking about institutions and research and a few of those things, right? So let's quickly go over a few tools. So essentially, Phi data is a framework that is used to build agents, right? All the things, the framework, the internal components are provided by Phi data, the library, right? It's a library that has implemented the agent framework, right? Including the orchestrator, the executor, the planner, the memory, the long term, the short term, right? It's a framework that is available out there. Now, the interesting part that I wanted to show was tools, right? What are the tools available which you can use with this framework for which are already available, right? So first, number one, you can use literally any Python function in this case, right? In case of Phi data, you can any literally use any function as a tool, right? This function says get top hacker news, right? Hacker news stories. Now, this is going to this URL. It is getting the JSON of top stories from Hacker News Firebase. It's then doing some things and then essentially is returning the stories in a JSON format, right? So this can be used as a tool, and then you can define an agent that, you can say that, hey, agent, you have this tool available with you. If you need to go to if the user asks anything related to news, you have access to go and get the news and then work with your things, right? So now we are talking about like the agentic system working, right, in place. So let's look at a quick example. We are over here looking at an email agent, right? Over here, I have given my email agent three a couple of inputs, right? So a couple of tools. One is email. It can actually use my email ID and password, which I have masked over here. It can actually use my email ID and password to send an email, right? Then I have an argziv toolkit. Everybody knows about argziv. If somebody does not, please tell me in the chat. I can tell you what argziv is, but essentially it's a place to read research papers. It's like somewhere you can like read open source research papers, right? You have DuckDuckGo, which I also have provided as the list of tools. So my agent can access three things: search, which is DuckDuckGo, Argziv for finding research papers, and email for sending me an email, right? Now, I have asked the agent, right? I've created the agent. I have also asked it to print out the tool calls. I've asked the agent, send an email to the receiver email. Receiver email is my own email, right? In this case, because we are testing over here. send an email to the receiver email presenting a research on which research topics among all the publications are trending and are being used by the industry. Compare the latest publications to the latest news in the industry found online. The topic is agentic AI because why not, right? For every article related to the industry news found online, provide a link to the article. The email should be in markdown format, right? Let's try to run this. We can see here the agent is thinking. First information that it gave us was, hey, I'm searching argzip for uh, 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 the uh, I'm searching argzip for papers, right? It's still thinking. Let's wait for it to think. This is what I mentioned when it takes latency. It's slower than ChatGPT, right? Another thing that it did, we have a question. I'll just complete my flow of thought. We are going to open for questions right now. I know we have just 1 minute left, but if anybody has questions, I can wait. So whoever has questions, there's just 1 minute left. I'll quickly complete my flow of thought and take the questions, right? So we can see in the response here, we can see that it is running search, archive, and return article. So it decided that I have to use this function call, right? And then the other thing that it did was to go on DuckDuckGo and find the news relating to agentic AI. After that, it ran an email and it shot an email to me, right? So if we try to open that email, right? It's I can show that email.
The screen is not refreshing.
Yes, yes, yes. I am just showing that email out. Is it visible now, my email?
Yeah, but the previous steps were not visible.
Oh, yeah, that's fine. So just my email is visible right now, right?
Yeah.
Okay, beautiful. So, right. So this email I have received at 5:29. My local time is 5:30. So just 1 minute ago when I ran that, right? It says, hey, I have compiled an analysis of recent academic publications. We have the Kaka CACA agent. It is the live mint, which has like reported industry insight. It aligns with the trend of AI making independent decisions. So essentially, this is useful for research assistants. It's useful for people who are doing research. So with that said, I will quickly switch back. We are already 1 minute overdue. I'm really apologetic for that. Let us go back to the presenter view. Yeah. Oh no, not this one. Sorry. I will quickly reshare my screen. Okay. Yeah. All right. So with that said, uh, we can open for questions. We can open up for questions. I'm really sorry we overspilled the meeting. We can open up for questions.
Right. Thank you, Prathmesh. Is there any questions?
We had a question. I did see a hand. We did have a question. Okay, beautiful. So thank you, everybody, for being patient and attending the session. Thank you for listening to me from the past 1.5 hours. I really hope that everybody who has attended today got to learn uh, a bit, and I hope this knowledge sticks with you. And if I hope you can really take that back, right? If anybody wants to connect with me on LinkedIn, you do see and you have been seeing my LinkedIn profile link at the bottom. If you want to talk to me, anybody wants to talk to me, connect, whatever, you can send me an email, LinkedIn, whatever. Sneha, we have a question. Mm-mm. Okay.
Sneha, madam, can you ask your question? Or
All
okay.
right.
Yes.
That's my time. Thank you so much.
Yes, thank you so much, Prathamesh, for spending your valuable time and giving such a valuable information on some topics which is not covered in generally with respect to academic, part of it. So I really appreciate you giving so much amount of your dedicated time for our FDP. To sum up, it was a wonderful session. I hope our participants have gained much knowledge on what you have said. And with the quiz, it was much interaction happened, and I could see that multiple, people have given the correct answers. That means yes, something has obviously been understood by them. This is what we can infer from that. On behalf of Artificial Intelligence and Data Science Department and VIT, I would really like to extend sincere thanks to you for you know uh, giving your dedicated time out of your schedule for this FDP, and hopefully we'll collaborate more in future for such kind of sessions, Prathamesh.
Absolutely, Sabina. Thank you so much. Thank you, everybody.
Yes, by this I'll say that the session has been concluded for today.
All right. Bye bye. Have a great day.
Yes, yes, same to you. Yeah.